Well, you got your straight lines, and you got your up and down lines, and you got your left and right lines, and your... Well, heck, we got lines all over the place. Let's talk about some linear functions. All right, we're continuing chapter 5. This lesson is all about analyzing linear functions, and we're going to be talking about two main things in this section, and that would be writing linear functions given different situations, and also finding different ways to find the rate of change, which is also going to be called the slope. All right, so in your notes, this first section, let's start off with this first example. I'd like you to read it through once, so if you want to pause it and just read it through, that'd be great, and then I'm going to read it through as well. All right, it says, Wilson Middle School has money left over from last year's fundraiser. This year, students are selling discount cards for local businesses. The graph shows the leftover money and the amount the school will earn for each card sold. Write an equation that shows the total amount of money the school will have, including the leftover money and the amount earned selling X number of cards. So it is linear, so we're going to kind of write it in this y equals mx plus b form. And I'd like you to try to see if you can figure that out based on the graph. So how'd you try it? Well, there's a couple things that we need to know. If you think about y equals mx plus b, what we've learned so far is this is our initial value, and this is, the m is our rate of change. And the x and the y stay as x is y, because y is going to be our total and x is going to be our number of cards. So our initial value, you might remember, is where the graph starts, especially if it's all positives. It starts right here at 100. So that means they had $100 to start this thing. So I'm going to put that in for B. So 100. I don't know that middle part yet, that rate of change. So one of the ways we learn to find rate of change, if we wanted to find rate of change, and I'll put it up here, we can do change in y over change in x. Or we've also learned vertical change over horizontal change. And in this case, we're dealing with a graph, so vertical change over horizontal change makes more sense. We're going to call that something else. Vertical change and horizontal change is more commonly known as, it's actually more commonly known as rise over run. Rolls off the tongue a little bit better. Rise over run. I should probably spell it right, though. Rise over run. If you think about rising, that would be the vertical change going up and down. Run would be left to right. You run forward. You don't run up or down. So rise over run. So if you can find 2 points, just like we have in the past, find 2 points on here. And I'll take this one, and that would be at 10 and 120. I'm going all the way to this one, which is at 20 and 140. The rise is up 20. The run is over from 10 to 20. It's also over 20. So 20 over 20. The rise over run is 20 over 20, which actually equals 1. So our slope, or our rate of change, is just simply 1. So 1x plus 100. And there's my equation. Y equals 1x plus 100. Even though it doesn't look like it's going up 1 every 1, it's how it's numbered. It does go up 20 every 20 over. Backtrack. I found a mistake. There, you found a mistake. It does not go over 20. It only goes over 10. From 10 to 20 is over 10. Oh, can't believe it. So 20 over 10 is 2 over 1. Or just 2. 2 over 1 means $2 for every card. If you're looking at the problem, we're going to use the number 2 as our rate of change. So I'm going to change this to a 2. So y equals 2x plus 100. There's our linear function. All right. I'd like you to take a look at the questions at the bottom. Pause it for a second. Answer these questions on your own. All right, first one, what does x represent? Well, that one said it in the problem. It said x was the number of cards sold. What is the rate of change? How did you get your answer? So the rate of change we said was 2 over 1. And we used the slope formula, which would be, we used rise over run on the graph. What does the rate of change represent? Well, again, we talked about that too. It was $2 for every one card. All right, D, what is the initial value and what does it represent? It was at 100, and that means they started with $100. And use your answers to write the equation that shows the amount of money the school will have, including the leftover money and the amount. So we said 2x plus 100. Y equals 2x plus 100 was our equation. So that breaks it down a little bit more for you. All right, now the other main thing I wanted to talk about in this video is going back to our equation, y equals mx plus b. Okay? This actually has a name. We haven't given it its name yet. It's called the slope-intercept form of an equation. Okay? And the only two things we put numbers in for are the m and the b. And the m and the b really are, we've been calling this the rate of change. That is a common term for it. But it's also known, especially with a graph, as the slope. So we're going to start using that term slope a little bit more. The other part, the b, is that's our initial value. That's what we start with. But another very common term for that, especially when you're dealing with a graph, is the y-intercept. And that's one of your vocabulary terms, the y-intercept. Because if you think about the graph, we're going to go back to our last example. The last example was right here. It's where it intercepts the y-axis. And that's why it's called the y-intercept. So two terms that I'd like you to get more familiar with. And that's what we're going to work on, finding those two things different ways this chapter, this part of this chapter. First thing I want to focus more on is finding the slope, two different ways. First one is on a graph. Something that we've done before. We've talked about it as vertical change over horizontal change, or rise over run is very common. So in graph A, in graph A, find 2 points that you know are on there. So this is definitely one point where it starts, and this looks like it's a point as well. So the rise is 1, and the run it goes over 2, so our slope would be just 1 over 2. Okay? Let's try this one. Again, it's starting at 0. It doesn't always start at 0. Let's take this point and this point. Looks like it goes up 1 and over 1. So the slope is 1 over 1, or just 1. Last one, try graph C on your own. Find 2 points and find the slope. All right, I found this as a point for sure. I found this as a point for sure. It goes up from 2 to 4. Goes over 1. This one is 2 over 1, or just simply 2. So that's that one formula. So for slope, we've got rise over run, also known as vertical change over horizontal change. The second one that's a little bit newer, it is definitely newer, and I want to talk about this one today. This is the last main thing I want to talk about, is if you're just giving two ordered pairs, so like right here, 2 coordinates, not even on a graph. Now you could certainly graph them and do rise over run, but if you don't want to take the time to make a graph, there's a formula for it. This is another slope formula. y2 minus y1 over x2 minus x1. So you're probably thinking, what the heck? Why is there a little number next to it? Why is there a y2 and a y1 and x2 and x1? I thought it was just x's and y's. Well, if there's 2 points, we got to somehow label them differently, because we have an x and a y right here, and we have an x and a y right here. So in order to tell the difference between the first x and y and the second x and y, we put a 1 and a 2 by them. All this means is we're looking at our first x and y. So we have a little 1 there because it's our first x and our first y, our first ordered pair. We have a 2 by these because it's the second x and the second y. It's the second ordered pair. So to use the formula, on the top, we look at the y's because it is changing y over changing x. Take the second y minus the first y. So this is our y2, and this is our y1. So in this one, I would take negative 15 minus 0. And on the bottom, I would take the x2 minus x1. So this is our second x, and this is our first x. So it would be negative 11 minus 3. And all I have to do is subtract. Negative 15 minus 0 is negative 15. Negative 11 minus 3 is negative 14. So my slope is... I just want to make sure that's in the right spot. All right, my slope is negative 15 over negative 14, or if you know anything about negatives, they cancel out, so it's just positive 15 over positive 14. All right, so the slope is 15 over 14. Seems a little weird, but that's just what the slope would be. Every 15 times you go up, you go over 14. All right, second one. Let's do the same formula, and let's label them right away. This is my x1, and this is my y1. This is my x2. This is my y2. So to find the slope, I'm going to do y2 minus y1 on the top. So that's 16 minus 8. Second y minus the first y. On the bottom, I'm going to do the second x minus the first x. So that would be 9 minus 20. Okay. If I subtract, I get 8 over negative 11. So you go up 8, and then you go back 11. So my slope is actually a negative slope. It's 8 over negative 11, or just negative 8/11. All right, last one. I'd like you to try this one on your own. Use the formula, find the slope. Go ahead. All right, y2 minus y1 is 3 minus 3. x2 and x1 is 20 minus 19. I get 0 on the top, I get 1 on the bottom. What happens when you divide 0 by 1? Or by anything, you get 0. So we have a 0 slope for this one. It's just going to be a flat line. You could graph it to see the same thing. So that's a second way I want to work on finding slope. And it's going to come in very handy with this formula. All right, last thing I'd like you to do, on your own, reflect what number will the x-coordinate always be in the ordered pair that identifies the y-intercept. We're going to actually start with this next time, so let's finish right there. Again, that's what we're talking about. We have our y-intercept, our rise and overrun for slope. Different ways to find slope today, continuing with linear functions. Have a great day, everybody.